jy. Then what is the velocity of this point P? Will be towards left. So how the friction will act? Forward. And sudden increase in normal contact. Suddenly normal contact will come into existence and will be very large value. And the point of contact, this particular point of contact, this particular P, that will have velocity in what direction? Towards left because of r omega naught anti-clockwise. So therefore what happen? The velocity of this point will be towards left. So the plank will exert friction towards right. This friction acting for small duration of time will become impulse. That will be impulsive friction. Then it will approach with a velocity v naught. It will rebound with a speed v1y. Because of this impulsive friction acting, it will acquire velocity v1x. Then impulsive friction will act on the plank in this direction. Then angular velocity has to change, cannot be same. Why? Because of this jx will set up angular impulse. I think problem is over. Sir, why jy? I think you know enough of collisions, no? When the ball spinning, it's spinning and coming that one, it'll strike that one. So the ball will be in contact with the plank for small duration of time. Normal contact will act. The normal contact due to sudden increase in normal contact force and impulse. Then this point P1 of this lower point will have tangential velocity r omega naught. Then the surface between spear and the plank is rough, so there'll be a friction. Suddenly this friction will act and F equal to mu n as F is equal to friction will act suddenly F into delta T. So mu n delta T. F into delta T is Jx mu Jy. So because of what is this impulsive friction Jx here? So similarly, the impulsive friction, sir, why on the plank? Because friction F and F. If friction acts on the spear towards right, friction should also act on the plank towards left. Action reaction equivalent and opposite. And just after impact, how the velocity of the plank will be like this. Okay, let's write all possible equations first. What is the velocity of rebound? Velocity of collides is telling. So shall we write all the collisions equation? V1y equal to EV naught. So what is Jy is equal to M V naught, M1 V naught minus J1y or Jy. Now what is this equation? Impulse momentum equation. Initial momentum m1 v naught minus jy is equal to m1 v1y. Y negative sign opposite initial that one. So from this m1 v naught plus v1y is equal to jy. Jx equal to mu jy is what we have. Why this v1x will come? Because of impulsive friction. So next equation will be I naught omega naught minus jx into r is equal to I naught omega 1. Angular impulse, angular momentum equation. Then this Jx will also set up impulse. So Jx equal to m1 v1x. Then on the plank, it was initially at rest. So Jx equal to m2 v2. What is Jx? Mu jy. And we know jy how to calculate from here. Now tell me what happened to the path of the ball. The path of the ball will be somewhere like this. No? Again, what will happen? It will come and collide. So here the ball, I'll show a little bit small diagram. Angular velocity will not change in the air. Of course, v1x will be as it is, but v1y has to change. No? Now why v1y dash? Because the weight mg will act. It will be spinning and again come and strike. Is asking now find the distance on the plank between first two impacts of the ball. So it's a long plank. The first impact occurred at A. Next impact will occur at B. I think by the time it will be moving, no, the plank will not be there. You have to calculate the distance here. Can you work out this? So I'll give the relative diagram. So here it will be this is a point A initially. After some time, the plank will be somewhere here. The ball, what happened, will describe a trajectory. So here it will have v1y, v1x, and omega 1. So it will come in, let it come and strike at point B. The B will be somewhere here initially. So it's asking that distance. And after some impact, that A will be here. Is asking that distance AB. Able to, and the plank will continue to move with that velocity. After impact, it will change. This is just before impact, just about to impact. It's asking the distance AB here. So for that, what is the method? I think you have to go for what is the maximum height ascended. I think that V1y will determine time. No? In that time, what is the relative separation between the point A and point B? So what is the method? You're going to calculate first time. Then what is the distance AB should be equal to? V1x minus of minus V2 into time. Will I agree this? Directly, no need to draw much diagrams if you are having relative velocity idea properly. Why minus of minus? Because the center of mass of the disk will have a displacement. Even the point B of the plank also will have displacement. If plank were at rest, it will strike here. Since the plank is moving, no, so by the time when the sphere is about to strike the plank, it will strike at the point B. I think some diagram. Rough diagram I'm showing it. So is that okay? The distance is asking. So V1x, V2 and time of. What is time of flight? 2 V1y by g. So substitute this to get the required answer. See applications now slowly what happened? Rather than core rotation mechanics, we are going for application. You see that one. Different situations, what are the ideas will be involved. This, I'll explain some concepts. Suddenly hinged. This is again one more very simple thing is there. You might have experienced this in your day-to-day life. Rigid